Hello student, myself name is Prabhakar. Welcome to Process, Dynamic and Control lecture series. In my previous lecture, I discussed about the mass balance and energy balance equation of distillation column. Now, in this lecture, we will discuss about the control of distillation column. That means, in this lecture, we discuss the control strategy of distillation column. And in control strategy, we discuss about the control of overhead composition. Then we discuss about the control of bottom composition. And last, we discuss about the control of both product composition. So here, in this lecture, we discuss about the control strategy of distillation column. So you can understand here the control strategy of distillation column is divided in particular three parts. That means first one is control of overhead. That means first we control the distillation. Then after we control the control of bottom composition. That means we control the bottom product composition. And last we control both, that means bottom and overhead, both we control in the last. So now we start with the first one, that means the control of distillation column. So first we basic understand what is the control of distillation column. So here you can see this is the basic diagram of distillation column. So here this is the distillation column, and then we can see this is the accumulator, and in the bottom part we can see this is the boiler. So now most of the distillation column system, either conventional or advanced, assume that the column operates at a constant pressure. Pressure fluctuation make the control more difficult and reduce the performance. The LV structure, which is called energy balance structure, can be considered as the standard control structure for a dual composition control distillation. So here we use the LV structure. That means this is the most important, and it is also known as the energy balance structure for the controlling of the distillation column. In this control structure, that means in the LV structure, the liquid flow rate, that means L, and the vapor flow rate V are the control input. That means here we control the liquid flow rate, that means L, and the vapor flow rate, that means V, is the control input. That means here the LV is named given by the liquid and the vapor. The objective of control is to maintain the product output concentration XP and XT. That is the bottom product concentration and distillation product concentration, despite the disturbance in the feed flow and the feed concentration. So here our aim is to control the concentration of XP and XT, that means bottom concentration and control of distillation concentration, without the disturbance in the feed flow. That means we give the input feed flow and the feed concentration, that is known as the CF. So here this is our aim of the controlling of distillation column. Now we start with the control of overhead composition. So these are the method of controlling of overhead composition. So first one method is a direct control of D. second one method name is indirect control of D, and the third one method is known as decrease the vapor rate when the overhead purity drop. So these are the three methods or the three cases we can say is used to control the overhead composition. So now we discuss one by one, and we start with the first one method, that is the direct control of D, that means distillation. So now we discuss about the first one method, direct control of D. Here you can see this is the diagram of this method. The most direct scheme of controlling XT is to use the single form, the composition controller, to adjust the distillate flow. So here this LC is indicate the level controller and CC indicate the composition controller. So here you can see this is the LC and CC is two controller is used. The reflex flow is adjusted by averaging time level controller, that means LC, and a decrease in D will eventually produce an equal increase in R, that means reflux flux. The reflux drum or the accumulator serve mainly to keep a liquid cell on the reflux and the product line and to provide a designing space for the non-condensable. Large accumulator can be a help in damping changes in flow and in providing a reservoir of high purity material for reflux. But then they have sometimes made control worse because of inadequate mixing in the tank. So this is the advantage of the large accumulator and disadvantage of large accumulator. So here the advantage of large accumulator can be help in a damping change in the flow and also help in providing a reservoir of high purity material for reflux. But it also has one disadvantage, that is they have sometimes made control worse because of the inadequate mixing in the tank. So this is the direct control of distillation. Now we discuss about the second one method, and its name is indirect control of D, that means distillation. Here you can see this is the diagram of indirect control of D. Here we use same LC, that means level controller, and composition controller CC. Instead of controlling D directly, the composition controller can be adjust R and the level controller can be adjust D. So here we instead of direct controlling of D, the composition controller, that means CC, can be adjust R, that means the reflux flux is adjusted by composition controller and the level controller is adjust the D, that means distillation product or overhead product. This has been more popular than direct control scheme, though it has no apparent advantage. For very high reflux ratio R by D, this scheme seems particularly sensitive to offset. So here we can see there is some limitation. For high reflux ratio R by D, this scheme seems particularly sensitive to offset. Now we understand the last one statement by help of this one example. So here we consider if V is equals to 550 and R is equals to 500 and D is equals to 50. A slight change in V to 560, that means here we change due to some condition or load change, there is a change in the V, that is 552 is close to the 560, would be lead. So due to that, the D is also changed. So D is changed from 50 to 60, a 20% higher flow than the desired flow, until the composition controller senses the change and increase the reflux. In direct control scheme, the extra vapor flow would be returned as reflux without distributing the product flow. This scheme would also be more sensitive to change in reflux temperature. So this is the another disadvantage or limitation of indirect control scheme. That means this scheme would be the more sensitive to changes in the reflux temperature. Now we discuss about the third one scheme of the overhead composition. See, this is the diagram of third one scheme of control of overhead composition. So this method of controlling the overhead composition is to decrease the vapor rate when the overhead purity is dropped. So this is a simple funda or the aim of this scheme. That means it's decrease the vapor rate when the overhead purity is dropped or decreased. The reflux flow is controlled at a fixed value, and so the lower value of V actually means a lower value for D. The wide separation of sensing element and the control flow is made from a dynamic standpoint, and the system is slower than the first two schemes if sensing element is almost at the top of the column. So this is the limitation of this control scheme. However, if the sensing element is several plates from the top, the third scheme, that means this scheme is faster than the other because a change in vapor flow is transmitted through the column much faster than a change in liquid flow. So this scheme becomes very effective when if the sensing element is say the plate from the top. So the third scheme, that means this scheme, is faster than the other scheme, because the reason is that a change in vapor flow is transmitted through the column much faster than a change in liquid flow. Now we discuss about the control of bottom composition. That means here we discuss about the bottom product composition. So this is the diagram of composition of bottom composition. So here we use two schemes to control the bottom composition. The method of controlling the composition of bottom product are shown in this figure. When direct control of bottom flow rate is used, the flow of steam is adjusted by the reboiler level controller. So here, same as we use LC and CC, that means level controller and composition controller. So in the first one scheme, in this diagram, you can see a direct control of bottom flow rate is used. The flow of steam is adjusted by the reboiler level controller. Now we discuss about the second one scheme. The second scheme has the reverse arrangement. The composition controller regulates the flow of steam and the level controller at a constant rate, and the overhead product rate is adjusted by the reflux drum level controller. So here, this is the second one scheme. This is the approach is reverse. That means composition controller regulates the flow of steam and the level controller at a constant rate, and the overhead product rate is adjusted by the reflux drum level controller. So these are the two schemes for the control of the bottom composition. Now we discuss about the control of both product composition. So you can see this is the diagram for the controlling of both product composition. By controlling the distillate flow rate, the overhead composition XD can be generally be kept constant, that means in steady state, in spite of change in the feed composition. However, the concentration of the bottom product XB does change as the feed composition changes. If the feed plate is correctly located for a normal feed, a shift in feed composition means that the feed is now introduced too high or too low in the column, which tends to decrease the separation that is achieved. The separation can be increased by using higher vapor rate and higher reflux rate. Therefore, from a steady state viewpoint, both XD and XB can be controlled by varying D by F and B by F independently as shown in figure. The condition need to keep both product composition constant can be calculated by using either McCable-Themin diagram or the plate-to-plate calculation. So you can see this is the diagram, and this is the last one method, that means control of both product and composition. So in this lecture we discussed about the control of distillation column, and in this we discussed the control of overhead composition, then we discussed the control of bottom composition, and last we discussed about the control of both product composition. Thank you.